Thank you for staying for, I think, one of the last lightning talks. So I'm Ben, CTO and co-founder of the company Armo, and also one of the maintainers of the Kubescape CNCF project. Now, do you like memes? Do you like memes? Yeah, okay. Do you like project maintainers whining? Yeah, okay, so this talk is for you. So I'm going to use a lot of memes. Actually, this is like the only slide without meme. So just a few words about Kubescape. Kubescape is a CNCF project in incubation. Kubescape is a security platform for Kubernetes. We are doing a lot of scanning and producing data stuff. We are scanning for vulnerabilities, configuration issues. We are generating network policies, seccom profiles. We are doing runtime threat detection, and we are doing application profiling and creating these application Kubernetes object called application profiles. What it does is actually produces a lot of data. So we're thinking, okay, what do we do with this tons of data that we are producing for the users? How can they tap into this data? And we're really contemplating about, okay, whether we are like just creating this Kubescape API server where you can just like bring these objects and read them and like use them as you want, or you will publish them as Kubernetes API objects. Do we like Kubernetes API objects? Of course we do. They are lovely. Like, okay, now the next questions is, okay, where do we store them? So do we define them as CRDs, Kubernetes Custom Resources, and let just etcd store them? Or do we use an aggregated API server with the Kubernetes API? So is there anyone who knows what an aggregated API server is? Hands up. Okay, so you guys, but you don't count. So the point is that you can create your own API server within the Kubernetes cluster, and the Kubernetes API server will just like forward all the requests to your API server. So you can still, be super sleek, like tapping into, whoa, no memes for you. So tapping into this super nice Kubernetes API ecosystem, like using kubectl to get objects, K9s, lens, headlamp, like all these things, and it's like super sleek. It's super duper, but the problem was when we needed to start to scale this information with huge cluster deployments, and you see the sweat, like we were sweating. And in this talk, I'm going to show you like a few things that made our lives hell and how we solved it. So one of the options in Kubernetes API is to store Kubernetes objects and then list them. Now it's super nice to list like YAML files, like deployments and pods, which are like usually smaller than 4K. But what if you have an SBOM, which we scanned for, and it is like 100 megabytes of object, and you are listing it for a namespace, and you have like 100 of them. So obviously, no one could really, build the Kubernetes API concepts weren't built for this at the beginning. So we had a really hard time to supporting this. The second is that the watch verb. So it's like super, again, for small objects, for objects that are not changing too much, it's super nice to have this watch option in the API that you're watching that something is changing, and you have this open HTTP call, and like if there's a change, you are just getting the updates. But the problem was for us that it's really, really hard, again, because of big objects, because of, maybe it's not really needed in the security world to watch things, like you don't necessarily need to get these live updates of vulnerability scans, maybe, or for even, I don't know, application profiles. And it made us a tremendous effort in our storage component to just back this Kubernetes promise up. So it was like super duper hard. Another thing was that, okay, patching. Kubernetes API is super nice to changing like, fields within objects, which is, again, amazing for scaling up a deployment and patching like, a single field. But if your objects are very complex, very big, nested objects over nested objects, and like have these huge lists, and what do I do? Do I add to the list or replace them? It's super hard, super hard for me. So to support those. So therefore, we had really hard time. And the last one of our biggest headaches were like really crashing clusters at scale at the beginning, because one thing is that that we are an API, we are producing API server objects, but what happens when there are like these unintentional users who we never meant to use this API? For example, Argo CD starting to start to scan for objects, and resource quota manager in Kubernetes are hanging our APIs, and these were just like making API requests in ways that we never imagined that someone would. So these things were like super hard for us. So what was the way that we made this stable and scale to clusters of like 200,000 of nodes? So we started to just align more the APIs to support our use cases within the realm of the Kubernetes API paradigm. So on the one hand, we enable listing objects, but we are not relisting the objects themselves, but their metadata. So if you want to pull the object itself, you need to make a particular request to that object, and the list verbs are just bringing you metadata. So this way, we can only serve metadata there. So someone can list what they have, but they won't get the full object on the list itself. The watch is right now very limited we're limited in Kubescape, and we are eventually will deprecate it. So watch is just like simply something that we don't see that there is a real use for that, and it's just like nuance that it looks nice, but it's just a horror for us. We don't stop support resource versioning, which was again a headache and doesn't really make us any advantage. And instead of doing these custom patching mechanisms of like extending objects and writing into existing objects, we started to implement some custom object logic. So for example, you cannot patch an object, but if we want the same idea, then we have these sub-objects that we are aggregating into bigger objects in our world. So think about it in a way that when we are constructing application profile which represents a deployment, we are building it from smaller objects that represent container instances. And this way, we can avoid like very complex patching logic that requires us to load a lot of information into the memory. And we obviously started to do a request querying in a way that we are avoiding, the ability to block other components that were like really hurting us. So. Thank you for your attention. If you are interested in Kubernetes security and how we can help you, meet us at the Project Pavilion. We are going to be here all week. We love to talk to users. If you're already a Kubescape user, shout out to you, and come. Since we are in incubation, we don't need you to attest your usage, so we are fine. But we are still happy if you are saying hi. So. Please come say hi, and have a great KubeCon.